Hello, welcome to the workshop. In this episode I have NAD stereo amplifier model 3225PE for repair. I like NAD equipment. I own a couple of other units right now. I use a more modern integrated amplifier C350 here every day, and I also have a receiver model 701, and I owned a couple of other units before. To my taste, they offer quite a good balance between sound quality and price. This model is quite old, probably around 1990. Someone tossed it out, and apparently this is an unfinished repair attempt. The cover is loose, and also the bottom plate is loose, and the screws are missing. And there are some other signs of an unfinished repair attempt inside. Let's have a look. This is an old school design, no integrated circuits at all, transistors only. And unfortunately, this old design does not have much protection against shorting the output. There are fuses here and PTCs, but they are not fast enough for such a case. So shorting the output is almost guaranteed to kill the output stage transistors and probably will cause some other cascading failures like transistors in the previous stage and some other parts around them, resistors and so on. Maybe this is what happened here, maybe there was some other problem, but I see that someone tried to fix the left channel. This part of the board is power amplifier. This is the left channel and this is the right channel, almost identical sections, like mirror images of each other. And these two transistors in the output stage of the right channel seem to be original. Date codes 8942 and 8939. So they must have been made in 1989. But these two devices in the left channel are much newer. Date code here is 0944 and 1001 here. And they are not even the same parts. This is a classic pair 2N3055 and MJ2955. NPN and PNP, and these are different, MJ15025 and 15024. And I don't quite like this. I would much prefer having the left and the right channels identical, and these transistors probably have quite different characteristics from the originals. And it's not even clear that this configuration worked, because I see a missing transistor here in the left channel. It is present in the right channel. And also I checked the fuses. Here are 4 fuses, 2 for each channel, and these 2 for the left channel are blown. And also I see a missing jumper here, like this one, for the left channel. This is between the preamplifier and the power amplifier. And I also see that 3 resistors in the left channel are not original. So it's not clear if this configuration worked. Maybe it worked for a while, then it failed and someone tried fixing it and did not finish, or maybe it never worked. And looking at the other side, I would guess that this repair never worked. Look at these legs of the replacement transistors in the left channel. Let's use this ruler. This is how close the bottom plate would be. So I can hardly imagine that someone would leave these legs that long if the intention was to screw the bottom plate back in place. Let's do some checking. Diode mode here. This device is NPN, so we put positive on the base. This is the base and this is the emitter. We have a diode here this way and collector. We also have a diode. Looks fine so far. Then we should see nothing the other way. Well, but we do see something. Perhaps that's because it is in circuit. And to collector, something is charging this way. And collector to emitter, something is charging here as well. So it's not quite clear because it's in circuit, but looks sensible. This is the PNP device, so we put the negative on the base and the emitter. Yeah, looks like a diode and collector. Here is a short. Let's try the other way. Yeah, same thing, of course. So we have a short base to collector here. And what about collector to emitter? Something is charging here. So base to collector is shorted on the PNP device, and it might be because of the previous stage. It's not clear. Perhaps it's time to start desoldering things. I want to replace the power devices anyway, because they don't match the right channel. I found the service manual with schematic, which certainly helps a lot. And on page 10 we have this piece of the diagram for this model with power amplifiers. Let's zoom in. And here they are. This is the left channel and this is the right channel. Not too complicated, just 9 transistors per channel. This is the output stage, and these boxes around the transistors mean that they are mounted on a heatsink, and this transistor is also mounted on a heatsink. And we've seen a short here between the base and the collector of this PNP device. And you see it can be easily because of this transistor in the previous stage. And I see that this resistor is not original because it is larger than in the right channel and it has a burn mark on it, but still measures fine. And I also see that these two resistors are not original. They are also larger than in the right channel. And this transistor is missing altogether. So I'm thinking that perhaps it would be a good idea to replace all these transistors just in case. I need to order this type anyway, and this one is of the same type, so I might as well replace this one just in case. These two are BD139. Must be cheap and easy to get. This one is probably dead anyway, and even if not, it might be damaged, and this one might be damaged, you never know. So I am tempted to replace all of them, and of course I need to check diodes and resistors and electrolytic capacitors as well. Here they are. 8 transistors from the left channel, the 9th is missing, and perhaps you can see that these big transistors have insulating mica pads stuck to them, so I need to carefully peel them off. They are fragile, and this transistor also has a mica pad between it and the heatsink, but that pad got stuck to the heatsink. Alright, I managed to carefully peel off the mica pads, and I wiped off the thermal compound from the transistors. Let's test them. These three are PNP devices, the rest are NPN. Let's start from the output transistors. Let's see if I can hold it like so. This must be the base. So we should see diodes here and here. Yes. Nothing the other way around. Yes. And nothing collector to emitter. This one looks okay. How about this one? PNP device. So we should see diodes here and here. Yes. Nothing the other way around, and collector to emitter, nothing. So this looks fine as well. Now the previous stage. This one is NPN and the base is here. We should see diode here, and we don't, and diode here, no, and the other way around, nothing, and collector to emitter, nothing. So this one looks completely open. This is PNP, so we should see diodes here, nothing, and here, nothing, and the other way around, also nothing, and collector to emitter. Oh, there you go. This is our short between the base and collector of the output transistor we have seen. Now this guy, NPN, and base is here. So we should see diode here, yes, and here. And the other way around should be nothing, but we see something. And collector to emitter does not look healthy at all. So this one is dead. This is of the same type. So we should see diodes here and here. Yes. And the other way around, nothing. Collector to emitter, nothing. So this looks fine. This one, base must be in the middle, NPN, so we should see diode here, yes, and diode here. This does not look healthy. The other way around, nothing and nothing, fine, and collector to emitter, nothing. So this one looks bad. And this one is PNP. We should see diodes here and here. Yes. The other way around, nothing, which is okay. And collector to emitter, nothing. So this one looks fine. This is not a conclusive test, but at least on the first glance, these two look fine, the output transistors look fine, and these four look bad. And let's look at the resistors. This is a 180 ohm resistor that is different from the right channel, and it looks a bit burnt. And these two also are different from the right channel. And it's not even clear to me on this 33 ohm resistor, is this a burn mark or something? It looks a bit strange. And also I see that this 68 ohm resistor is different from the right channel. And here they are in the right channel. This one is 180 ohm resistor. These two are 33 ohm and 220, and this one is 68 ohm resistor. It looks like a metal film precision one. I found that some capacitors are not very good. These two big ones look fine, but I found these two 1000 microfarads 10 volts capacitors. I desoldered one from the left channel and one from the right channel, and they are not very good. Let's have a look. 1 kilohertz, and let's set ESR as the second parameter. So this one is 194 microfarads and the ESR is about 0.4 ohms, and this one is slightly better, 266 microfarads, and ESR is slightly lower, 0.28 ohms. But for comparison, here is a good one. (940 microfarads) and ESR is about 10 times lower. This is how it should be. I ended up replacing quite a few of these capacitors all over this unit, including preamplifier. Some of them are not too bad, but I replaced them anyway, even if I had just a slight suspicion. And I also replaced these suspicious resistors. Now let's look at how these transistors should be mounted. Here should be those Mica pads we have seen before, and this smaller pad for a transistor like this is still in place. So these Mica pads should insulate the cases of the transistors from the heatsink. However, the case is the collector and there is no pin. So the only connection to the PCB for the collector is through these two bolts. So the bolts should not be insulated from the case. But look at this hardware. This fifth bolt is for that smaller transistor with a plastic case, so no insulation needed there at all. But look at these four. First of all, they are not consistent. These two look shorter, and this shake-proof washer looks larger than the rest, so it is probably not original. And these two bolts perhaps are not original. And most importantly, look at these two insulating plastic washers or bushings. I don't think they should be here at all. I think one such bolt was used per device, so there was still a connection through the second bolt. Not ideal, but maybe fine. This bolt does not have any insulation at all, and this one has this small plastic sleeve, and I believe this is how it should be. I don't want to disturb this mounting of the original transistors to check, but I'm quite sure this is the right way. This is just to insulate the bolt from the heatsink to prevent it from touching the heatsink. The hole here is much larger than the bolt and even slightly larger than the hole in the PCB, but they are displaced a little bit, so there is still some chance of touching, maybe small, but anyway, this is the right way. And how did this happen? I wonder, perhaps someone took this thing apart and then put the project aside for a while, maybe for some months or years, and the hardware was lost and the right way was forgotten, or maybe something else happened. Go figure. The parts have arrived, some from DigiKey, some from LCSC, and as usually I bought more than necessary. For example, these are BD139-10 transistors. I bought 10 just in case. They are cheap, so it's time to rebuild the amplifier. I'm going to use pieces of this heat shrink as missing sleeves. The size is just right. I wiped off the old thermal compound. Let's use some fresh one. The left channel is fully rebuilt. Let's give it a go. Here is my test setup. I'm going to use my Keysight scope with built-in signal generator. I have this BNC to RCA adapter. This we can connect to the input of the power amplifier. There is still no link between preamp and the power amp, so I'm bypassing the volume control here, so I need to control the signal level on the scope. And let's see if we can put something in and get something out of this. No load yet, because I believe we need to check the DC 0 point and perhaps adjust it before connecting any load. Everything is ready. The amplifier is off for now and the output of the signal generator is off. I set the output level to 100 millivolts peak to peak, 1 kilohertz. So let's turn the amplifier on and let's turn the generator on, and there you go. We have 1.8 volts peak to peak output. So let's bring the input up. Now we are at 300 millivolts peak to peak, and now about 500 millivolts peak to peak input, and the output is 7.7 or 8 volts peak to peak. This looks great. And now the same check on the right channel, just to make sure the right channel is working, and for comparison I removed the link. Same 500 millivolts peak to peak input and about the same 7.9 or 8 volts peak to peak output. Now let's check the DC 0 point. I turned the amplifier on a few minutes ago, so the voltage stabilized around negative 100 millivolts on the left channel, and I think it's too high. Let's check the right channel. And I don't have to reconnect the negative. I checked the schematic. In this amplifier it is the same ground. So here we have around 13 millivolts. So we need to adjust the DC offset in the left channel. Here is the adjustment procedure in the service manual. There are 4 adjustments here, 2 in each channel. This one is 0 point for the left channel. They call it center voltage. This one is idling current. And this is the procedure. Speaker impedance switch should be in 8 ohm position, which it is. No load connected. Then measure across the output of the channel and adjust to be within plus minus 30 millivolts. And for idling current, we need to remove solder shorts across 2 resistors, 1 in each channel. They are 1 ohm resistors in output transistors collector circuit. And we need to measure across these resistors and adjust to be within 26 to 30 millivolts. And then we need to remember to short those resistors again. I adjusted the 0 point in both channels. This is the left channel and I switched to millivolts, so we are below a millivolt. And it drifts up and down a little bit, and it doesn't have to be this precise, just within plus and minus 30 millivolts. And I adjusted the right channel as well. We had about 12 millivolts there. Now it's close to millivolt and a half, let's say. And now let's do the idling current. Here are the solder shorts we need to remove. This one is in the right channel and this one is in the left channel. Here is the idling current in the left channel. It is too high. Let's see which way I need to turn. No, the other way. It should be within the range from 26 to 30. Let's say around 28. Something like that. And this is the idling current in the right channel. It is just a tiny bit above 30 millivolts. Perhaps I'll bring it down slightly to the middle of the range, but I don't really have to. And I didn't have to touch the 0 point in the right channel as well. It was just fine. I found the right screws and put the amplifier back together. Now let's take care of the missing link for the left channel. I have this broken cable I keep in a junk bin precisely for such cases when I need to build something custom. So I'm thinking about taking these connectors apart and improvising something. The new link sticks out a little more, but it shouldn't be a problem. Those banana terminals stick out even more than that. Now let's give it a full test with some load and all the way through the preamplifier. I have this power resistor for testing. It is 50 watts, 8 ohms resistor. I am afraid that the marking on it is too faint and probably will not show on camera. And let's do a quick calculation, how far we can push things. I'm using Ohm's law here, very simple. If we multiply both sides by voltage, we get power on this side in watts. Here it is. And solving for voltage, we'll get this formula. Now we plug in our numbers. The amplifier is rated continuous power into 8 ohms is 25 watts and up to 40 watts clipping. So let's use this continuous power. That gives us 14 volts, and that is DC, or AC equivalent would be RMS. And I could ask the oscilloscope to measure voltage RMS, but we can easily convert to voltage peak to peak. First of all, we double it, because it goes both ways, positive and negative. And this factor of square root of 2 gives us voltage peak to peak, and that is about 40 volts. But let's not go all the way to the limit. Let's go to, let's say, 30 volts peak to peak. That should be good enough for a test. I don't want things to get too hot. Test setup is ready. A piece of plywood here just in case I don't want to burn the bench. I set 250 millivolts peak to peak output from the signal generator. I'm using CD in left channel. The amplifier is on, but the volume is at 0. Let's crank it up. There you go. Let's go to approximately 30 volts peak to peak. And here it is. No problem. And let's see, the volume knob is almost exactly at 3 o'clock. And now the same test on the right channel. This is about 30 volts peak to peak, and the volume knob is approximately at the same position. Great, no problem at all. The test would be incomplete if we don't play some music. I have these good old small Sony speakers. They sound great. They have 6 ohms impedance and can handle up to 50 watts. Let's try some copyright-free music from YouTube. There you go. NAD 3225PE repaired and tested. Thanks for watching. Bye.